Okay, so now I'm going to show you something else, how to get a volume by integrating more planes. Okay, so except that this time is not going to be a surface of revolution. You're not going to have some kind of plane curve or some kind of function curve that's going to revolve around an axis and it's going to make a solid. This time you're just going to have a triangular plane that's growing from zero and this triangular plane, the triangle is equilateral. And it's an equilateral triangle that's growing from zero all the way to a triangle of side equals 2. Okay, so this is what we're dealing with now. Here. Okay, a few things that you gotta keep in mind. This is the z-axis, okay, up here. All right, there's the y-axis, the x-axis. So y equals f of x in here is this line. Okay, the y equals g of x is this line right here. And it's on the floor. There's no z in here. Okay, now for us to find out, you can see that you got a triangle here. It's kind of hard to see, but there's an equilateral triangle right here. Okay, that is this size. Okay, fine. The big one in here, the one here at the edge, at the right edge, is going to be 0, of course. And the big one in here is going to be like this. Okay, so this is 2, this is 2, this side right here is 2, this side right here is whatever, but it's always an equilateral triangle. All the three sides are the same. So what do you have to do? What is going to be the volume of the solid? Well, it's going to be all the areas of all the equilateral triangles summed all the way from this big one, because we're going to integrate with respect to x. It'll go from x equals 0, which is this big triangle, to x equals 2, which is nothing. It's 0 right here, okay? And you can see that the sides from here to here, from here to here, and this top side here, that's coming down in here, okay? It's coming down, it's coming down, it's coming down. So this big side in here, all these things are shrinking linearly. This is very important. They're not shrinking like this. They're shrinking linearly, okay, like that, something like that. All right, so what is going to be the volume? Well, it's just going to be the integration with respect to x of all these plane areas, okay? So it's going to be the first plane area plus the second plane area plus the third. So we're going to have we're going to have an infinite amount of triangular areas, equilateral triangular areas, okay? And we're going to sum them up and get the volume. So let's try to figure out what is f of x first. So f of x, okay? What we're going to do, we're going to use the point slope equation to find out what it is. Now, I'm going to use this point here, which is the point 0, 1. So remember the point slope equation, y minus y0 equals the slope times x minus x0. This is from high school math, okay? In here, the y0 is going to be 1 and the x0 is going to be 0 because I'm talking about this point here. Okay, so it's going to be y minus 1 equals, I'm going to put an x minus, and the slope, well, it's going to be the rise over run, okay, from this point to this point. What is the rise? The rise is minus 1, okay? Minus 1 because the y is becoming minus 1 and the run is 2, so it's just minus half. So we're going to put divided by 2 in here, okay? So, oh yeah, it's minus. It's minus. Oh, okay, so y equals minus x divided by 2 plus 1, okay? This is going to be f of x. All right. I'm going to erase this. I'm going to erase all this and drag it up here. I'm going to erase this y equals here. Okay. Now I'm going to talk about the second line right here. Okay. Why? Why do I need these lines? Because remember the area of an equilateral triangle? Let me just draw. I'm going to draw it out here like this. Okay. Well, the area of a triangle is the base times the height divided by 2. Okay. The base we're just going to call L times the height. This height right here. Okay. Because this is 60 degrees and this is L. This is L. This thing here is L divided by 2. So here you have one of the sides, here you have another side, and here you have the hypotenuse of a right triangle here. Okay, so from Pythagorean theorem, you know that this whole thing here is L. Okay, this height is L square root of 3 divided by 2. So it's the base times the height divided by 2. So the area of an equilateral triangle, okay, the area of an equilateral triangle is L squared, okay, square root of 3 divided by 4. Okay. Now, what is L squared? I just want to show something here to you guys. L squared, well, this side here is going to be this side here, okay? Because what is L? L is going to be this distance here, guys. Look, it's this distance at this point, and at this point is this distance, and at this point here it's this distance, and at this point it's going to be this distance, okay? So what are these distances? It's f of x minus g of x, okay? Hold on. So let me erase that. So what's going to be g of x? Well, oh man, I forgot to change the color. G of x equals, the slope is the same one as this one, except that it's in the opposite direction. Okay, it's going up. So it's going to be x squared minus 1. Why do I know that it's minus 1? Because when x equals 0, y is going to be minus 1. You see right here? This point? Okay? So you have, so what do? We have to integrate, right? We're going to make the integral from x equals 0 all the way to 2 of the L squared times square root of 3 divided by 4. Well, square root of 3 divided by 4 is just a constant. I'm going to keep it out. L squared, let's see. L is going to be f of x minus g of x. So let's see here. F of x minus g of x equals minus x divided by 2 plus 1 minus x divided by 2 plus 1. Because I'm doing a minus here and a plus here, okay? So it's going to be actually 2 minus x, right? X minus x divided by 2 minus x divided by 2 is minus x, and there's the minus x. And 1 plus 1 is 2, here's the 2. So it's going to be this thing, 2 minus x squared dx. And I could do that thing, you know, we're going to integrate with respect to this. So it's going to be 2 minus x cubed divided by 3 and divided by the derivative of the first one. I could do that, but I'm not going to. Okay, divided by the derivative of the inner function here, which is going to be minus 1. So it's like this, but I'm not going to do that. I'm actually going to develop this thing here. I'm going to expand this binomial. Okay, so what is 2 minus x squared? It's going to be equal to 4 minus 4x plus x squared dx. Okay, because it's the square of the first minus twice the first times the second, okay, plus the second squared, the second term squared. Okay, so this is it. And now we're going to integrate this stuff, so it's going to be square root of 3 divided by 4 times from 0 all the way to 2, okay, of 4x minus 4x squared divided by 2 minus 2x squared, okay, plus x cubed divided by 3. Okay, you see that you got an x in here, so if you plug 0 anywhere here, it's just going to be 0. You don't have to worry about the negative part. Let's just worry about the positive part. It's going to be square root of 3 divided by 4 times what? 4 times 2 is 8 minus 2 squared, 4 times 2, 8, so it's going to be minus 8. And here you have 2 cubed divided by 3, so plus 8 divided by 3. This one cuts with this one, and you have 8 square root of 3 divided by 12, right? And you can just simplify, dividing by 4, you have 2 square root of 3 divided by 3. This is not an accident. Remember that I said that this whole thing here, look, the area of because what is the base of this stuff? The base of this thing, guys, the base of this thing is this big triangle here, okay? This is what we call a prism. I don't know if it's called a prism. Yeah, I think it's called a prism, a pyramid. This is a triangular pyramid, okay? It's triangular because the base is a triangle, and it's an equilateral triangle, okay? So this is a triangular pyramid, and whenever you have something that's very linearly, remember that I said that this thing was varying linearly until it gets to nothing. This thing here was varying linearly until it gets to nothing, and this side here, the height, was varying linearly until it gets to nothing. Whenever you have that stuff, it's gonna be the area of the base times the height. What is the height gonna be here? The height's not in z. The height is along the longitudinal axis, which is this way, okay? That's the height, divided by 3, because it's growing from the base all the way down to nothing, okay? In here, the area of the triangle is 0. So I'm going to prove that in the next exercise, on the next video, but it's not a coincidence that it was 2 square root of 3 divided by 3. Let's just say that this prism here was going to be the big area of the equilateral triangular area, okay, which is this thing here. It's this triangle over here, this whole triangle here. So it's going to be that whole thing, and as it went along the x-axis, it was not getting smaller. It was going to stay the same size, just going and going and going, okay? You got a triangle here, and it just keeps going and going and going and going at the same size. If it had not changed, the whole volume was going to be 2 square root of 3. But because it changed linearly down to nothing, it was 2 square root of 3 divided by 3. Right? 2 square root of 3 divided by 3. So that's what it is, guys. When you have a prism, for example, I just want to show something before we go to the next video. I want to erase this stuff in here. Okay. So let's say that we're going to have something like this. Okay. And then I'm gonna get here. This is being viewed at a perspective, at an angle. Okay, so here you have a cone. Okay, like that, and you can see that is varying linearly. Okay, this radius right here along the height, this radius is varying linearly. Okay, it's big one in here, and then it's smaller, 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 until it gets down to nothing. Right? So you see it's varying linearly here, Okay, now let's make something else in here. Let's do, I don't know how I can copy this. Let me see here. No, I need to start from here. No, maybe I gotta start from, see here. Yeah, I'm gonna do this. I'm gonna copy it over here. Okay, and now I'm gonna copy this thing. Tell you guys what I'm talking about. I'm gonna put it kind of over here. It'll be the same height. It's kind of the same height. Okay, and then I'm doing this here and here. Okay, this is what I'm talking about. This area is the same as this area, okay, but this one is varying linearly. You got a smaller circle in here, and a smaller circle in here, and a smaller circle in here, and a smaller one in here, until it gets down to nothing. Over here you got circles of the same size. You got this one, then this one, then this one, all the way to the bottom. All right, whatever volume of this volume here is going to be the same divided by 3. Okay, now for example, what is the volume of the cylinder? Okay, is going to be, if this is R right here, and this is the same R, okay, these R's have to be the same, and the height has to be the same too. So the height in here and this height in here have to be the same. Okay, so if this is the height, this is the height, this thing here is R, this thing here is R, the volume here is going to be pi R squared times the height. Okay, what? It's the volume of the circle here, it's the area of the circle times the height. What's the area of the circle? Pi R squared times the height. What is going to be the volume of this thing here? It's going to be pi R squared times the height divided by 3. It's always like this. It doesn't matter what the shape of the base is. It can be a triangle, it can be a triangular base, it can be a rectangular base, it can be a square base, it can be some kind of pentagon like this, right? An hexagon, hexagon, yeah. It can be a pentagon, like, I don't know how to write a pentagon, like, you're gonna have one more like that, I guess, here, and here, and here, okay. That's a pentagonal, hexagonal base, pentagonal base, so it doesn't matter. But as long as the height grows, or the height goes down, doesn't really matter. Along the height, the sides are getting linearly small until it gets to 0. The volume is always going to be this one. The volume of the cylinder or of the straight stuff is going to be the base times the height, and the volume of this, of something that's varying linearly, is going to be the base times the height divided by 3. Okay, so that's it.